Welcome everybody to this week's Tesena Fest. We're in week 3 of 4 weeks. First week we had a track about real life stories. Last week, good practices, and this week it's deep dive. My name is Phil. I'm calling today from Vienna. My production team is in Prague, and our speakers are from India, and I'm not sure where Filip is. Where are you based? You're in Bratislava or in Prague?
Closer to Bratislava. Okay,
closer to Bratislava. So it's a really international production day, and I'm sure we've got people listening in as usual from around the world. We are posting questions. We've got 3 talks, and we'll be having questions on Slido. If you're on the live stream, you can see the link to Slido down below. Please ask your questions. For the past 2 weeks, we've had fantastic questions, and it's been a great discussion after every talk. Also, we want to mention that we are posting all our content on our YouTube channel, so you'll see there a subscribe button. So we'll be uploading all our webinars and lots of other great content. So if you want to keep up to date with what Tesena is up to and you don't manage to get to the live webinars, then all the content will be on our YouTube channel. Every year we try to get better. And we'd like your feedback to try and make even next year or even next week even better than this year. So if you would be kind enough just to spend a few minutes, give us a little bit of feedback. What sort of topics we should be having? Should we improve it? Should we change the format? Is 3 hours in an afternoon too much? Whatever you want to tell us, we'd be really, really happy for your feedback. And we are going now to start. As I mentioned, today is track Deep Dive. We've got Varuna Srivastava starting off today, who's going to talk about automating Flutter apps. Then we have Filip Hric, who's going to talk about why wasn't that tested? I think that's something we've all heard as testers. We have Wittek, who's going to be talking about integration tests with Docker.
Okay. Good afternoon, good morning, good evening for the folks where you are. I'm Varuna Srivastava, a lead quality analyst at ThoughtWorks, and today I'm here to talk about what it is important to automate the Flutter apps and what were our initial challenges, how we cope up with it, and where we are at current stage. A little bit about myself, playing a role of a lead QA at ThoughtWorks, responsible for end-to-end delivery for the product and also for the definition of them, working along with clients for the KPIs. I'm a traveler, and you could find me on Twitter at a vibrant tester. You could find my blogs at srivastavavaruna.medium.com. So let's look into the agenda here before we take a deep dive into the session. So we are going to touch base upon the background. We'll talk about what is Flutter and the introduction to Flutter. What does Flutter consist of? What all features or what all things it gives us? And why Flutter driver? What are the different types of testing in Flutter? We'll touch base upon that. A live demo and a Q&A. So what is Flutter? So it's an open source toolkit built and led by Google for building an applications, mobile, web, and desktop. The beauty of Flutter is it is a single code base written in Dart. So as we all are aware of one or the other language like Java, JavaScript, or a TypeScript. So Dart is pretty much very similar to a JavaScript. You write your code in one class file, and that could get packaged and you could run it over your APK and IPs or even on your web. So you don't have to create a separate code base for a different platforms. And as you could see from the trends from the Google here, how the Flutter is coming across its last 1 year. It's more on people are intending towards Flutter, and we'll see why is it that shift is there in the people, and why is it like everyone who is starting to build a new mobile apps and who is thinking about the performance, accessibility, UI, it should work seamless in Android, iOS, low-end devices. So why Flutter? And it's more like what all Flutter promises to us. Now, what does Flutter consist of? As we talked about here, it's like a platform for a single code base for a desktop and mobile application. So tomorrow, if one of your client comes in and say that, hey, I want a mobile app also, and I would like to have a desktop application for the same, and I still do have set of customers. So here are your choices. As a developer, as a QA, we need a faster feedback in our entire development cycle. So Flutter developed the entire architecture of Flutter. If we look from the flutter.dev, it compromises of how we could have the faster development, how we could enhance the performance, and how we could have a beautiful apps. So you would see in the Flutter website, it always talks about the beautiful apps. So with the faster development, the hot reload is something which in and day out, if you are using Flutter, it will be helpful. You change some label name, you change your widget tree, and you just do a hot reload, and it will get then and there reflected in your app, and you could test it then and there. The performance, the most critical and the important part of the mobile applications. How is your mobile app performing on a slow network? How are your widgets getting rendered? How is your painting of the screen is happening? How are your icons and fonts looking on your different devices? And is it seamless on both the platforms? That's what Flutter promises. And we have seen with the apps in the markets for the past couple of years, 2 years, that yeah, Flutter is going there. Use beautiful apps as the iOS flavors, smooth scrolling. So these are the things which Flutter consists of, and why we should think about Flutter. Now, even though Flutter in markets, if you see here in Flutter Dev Showcase, BMW has developed their app on Flutter. You could also see Nubank, and there are n number of apps in the market based on Flutters. And the experience, what people and customer feedbacks are, they have a seamless accessibility, they have seamless scrolling features, font size are very much being very intuitive, painting of screen, even in the low network, even in the low end devices is seamless. And Google Assistant is also here. So we see here a pattern here that Google is investing a lot here in the accessibility. So one of my favorite apps which I would see here is Reflectly, and there are n number of apps which you could see in the market. So we know that Flutter is here in the market. So now why Flutter and why I'm here to talk around the Flutter? So the latest and greatest release of Flutter, if you see here, it's 2.5 release, which is September 18th. And the pattern what we see in the Flutter and the Google community all together, that they do frequent releases, they are trying to stabilize, and they are trying to fix issues. So in this current release of September 18, they fixed around 4,000 plus issues. Apart from those, the focus is always on performance is the pattern which you would see in the releases. How would you increase the performance of your app? What all better we could do to get the enhanced performance. Scrolling is something like when you have a big navigation menus and you need to scroll for your groceries and all. This is something which is very important when we look into our Android screen. And for Android screen, what they have promised in this release is Android full screen. So you could have your app in your Android full screen with a better scrolling. As you could see in the right hand side of mine, that this is just one of the scroll functionality and what the Flutter is offering to us. So stable releases, more performance, very frequent, community support, Google's vision is, and it's not only for the developer, what I would say here, it's also Google is trying here how we could make a testing being more stable here, how we could have a Flutter apps and how we could test those with more stable testing facilities. So with that, let's see what all are the things you could test using the Flutter apps. I'm sure we all would have heard about the unit test during our any cycle of development with any of the languages. So even in Flutter, we do have a unit test. The new keyword which came with the Flutter apps is our widget test. So the goal here is to verify the UI and the interaction on the widget. So suppose you have a click on the widget or you have a drop down on the widget, whether those drop downs and those interactions are working or not. That is what your responsibility of the widget test. Now next comes the integration test. Integration test is where you will test what your user journeys, what your personas are. If as an end user, whether I'm able to add an item to the cart or not. So there you will test, that would be your integration test. So whatever we have seen with our clients, the unit test and widget test is something which developer takes ownership of. An integration test is somewhere where the QAs comes into a picture and QAs own it, they drive it, they get it being running on your cloud platforms, and then they see how the reports are, how the performance is, and how the CPU utilization, profiling, everything. It's there on the integration builder. Now, since we talked around the integration test, it's what are the options and how, as a user, when I'm starting with Flutter, how could I start writing those integration tests? So before thinking about writing integration tests, let's see what all options we have. So it was back in 2020 when we started so for a Flutter, and it was also for us a new thing. And then people were worked before on the native, React natives, and then why Flutter. And same was getting applied for as a QA, that now you know that we have to have the integration test. So what are the different options you have available with which you could write your integration test? And what you could analyze it and what would be best fit for your product. So we took a decision to go with a Flutter driver at that point of time in 2020. And whenever I'm talking here in Flutter, or if I'm coming to the next Tesena Fest on the Flutter, since the frequent developments, so many things are changing in community. So whatever I'm saying now, today, it is just for today. It could change. You could see some latest and greatest blog post tomorrow, or some issues being fixed in Git. So even if we talk about the limitations, we have to be very careful and look into the GitHub issues when and there they are getting fixed. So when we were analyzing it and coming up with an options, so we were having these three things were there. Flutter driver, APM, as we all know, and many of us have worked on it in past, and APM Flutter driver. So APM Flutter driver was something which was being in a very starting phase at that point of time, even though it was an open source, but being the pace of the assignment we were into it, and also the way we have to identify. So the key thing where the Flutter comes here, the locators. How would you identify your elements? So when we played a spike around this Flutter driver, APM and APM Flutter driver, we figured it out that there were things which were not implemented in the APM Flutter driver, like a long tab, some of the unsynchronized commands, and how to identify those locators. On APM, also we were very starting when we were started with playing Spike, we were very much inclined towards that, hey, why not APM? But then we figured it out that the way we identify the locators in Flutter is based on your value key, and that accessibility ID is being missing in APM for the Flutter apps. And I've also mentioned here a GitHub issue at that point of time. Now, so that was our key challenge, that how would you identify any locators when you are trying to test your app. The thing was, then other thing came into us, like Dart is the language where the Flutter apps is getting built. Now as a QA file, and it's in my opinion, if I'm going to write a code which is being same written in the language which is being built, or test code, it is always an easy thing to get the latest update, to get the dependencies out of it, and to be not being going in a different direction altogether. And then what we started playing with whether we could run these tests on any of the cloud service provider. So there also we had an option, and we came up with a solution there that you could run these tests on AWS device form using a self, where you could provide all your needs. We would see in later slides and in demo that how the self.yaml looks like and what all you could provide and how you could get your, if you have your AWS account set up, how you could get these tests running there. And this is all other rules apply, same like pay as you go and other steps for AWS. So this was in 2020 when we decided to go with Flutter driver. Now, if you see, if you ask me on the current state, as of now, we have an APM beta also coming end of this year, which will have a Flutter driver. So let's see, fingers crossed, how is it coming across? And APM Flutter driver community is also working towards it. So in our assignment, our decision was to go with a Flutter driver based on these parameters, and also the community support and the issues what we were getting highlighted and what was getting fixed was also one of the reasons for us to get started with a Flutter driver. Now, how we came to know that what is Flutter, what does Flutter consist of, what are the different testing we would do for the Flutter mobile apps, for unit, widget, and integration tests, and then why the Flutter driver and what was the decision based at that point of time. Now, when as a QA, you are starting your testing and you are figuring it out that this is the new mobile app and what all things would help you. So these were the three things which has really helped us going, and not as a QA, even for a developer or anyone who is starting for the Flutter apps. These were the three productive supports which we did. Flutter Doctor. So this is the one where you would see what is your status, what is after your Flutter installation, where your export is working or not, how many devices have been connected, whether all your dependencies are sorted or not. So this gives you a verbose description if you have any issues around. Inspector, as if we had to draw the parallels, we could see that based on our browsers also that this is what the Flutter inspector looks like, and this will be helping to identify the elements and also to know how would you know the render tree of your widget. Dart dev tools. So Flutter is like why people choose Flutter. If we go across forums and across articles and even the proven mobile apps, it's more on the performance. And this is where the Dart dev tools help the developers or QA to debug it while you're developing only what is your frame per second, what is your CPU provider, and how is your memory utilization. So these would be the three tools which you would be using day in and day out if you are starting with Flutter, if you are starting testing or developing Flutter apps. As you could see here, this is how the Flutter Doctor looks like when you run the summary. And you could run with a verbose like what is your Android toolchain, what is your export, do you have what version of Android, and how many devices have you been connected. And you could also see here that no issues. Next is your inspector. Inspector is where you could inspect the element and figure it out that for element name label, this is what my value key is. So if you could see here, this is what the label text is, I'm going to enter some items. This is what my value key is. So as a QA, when I'm adding my integration test, I know what this value key is. And this also helps to figure it out what is there in my entire tree, and also helps in figuring out if you're testing something and if you figure it out that this is not the right font size. So those were the things like in the alignment, those would be the ways you would figure this out from the inspector. Dart dev tools, as we see here, it's all your performance, your profiling, your memory, your networking, what is your logging, how many requests are getting logged. So all these things you would get to see with respect to Flutter dev tools. And this is where it becomes very handy and very helpful in your day-to-day activity and in your day-to-day development life cycle. Now we have seen what are the helpful things or what are the tools we have. Now let's also look into how we would get started if someone has not ever done a mobile application development or someone has not yet done a mobile automation testing. How that person can get started easily and get onboarded on Flutter, testing Flutter apps. So getting started, any idea of your choice, whether it's a Visual Studio or Android Studio. The very first thing as we have, whenever we develop any of the frameworks, what we do add a dependencies. So in Flutter, you have a pubsec.yaml where you add your dependencies. And dependencies could be your driver dependencies, could be your third-party library dependencies. If you noticed here, this is OZ something which we are going to talk in the next slides, how it has helped us in taking screenshots, as our mobile app was somewhere for the trading platform, and for any single text or anything change in the screen, we need to go through the auditor approval before making it or deployed to production or making it available to customers. So every time someone taking manual screenshot was not something a feasible option for us. So we came with this OZ. We'll take a deep dive more here, more in the next slide for that. So this is the dependency. If you want to draw parallels, you could draw here with your Maven and a Gradle dependency like your pom.xml or your build.gradle, where you put your testng dependencies or your WebDriver IO dependencies. It's very much similar here also, that you start your product with your pubsec.yaml. Now these would be the few commands which you would be using it when you are coming across and whenever you are working across the Flutter apps. OZ. So why OZ? So as I touched base upon, what was our need? Our need was to get the screenshots for all our apps, like for all our screen, if we are making any of the changes, or if we are making even the change in font color or slide colors, we need to get the auditor approval here. So there were some things, screenshots were there in the Flutter, a diff image was there. But what we needed is entire zip folder where I could just give that when I run my whole test, and I could just give that to my auditor and he can just approve it based on the screenshots there. And here you can also customize the screenshots, like based on if you want to add an item to the cart, what would be my screenshot name and what are the different date and time of the instances. Also, you could capture it here. That's the reason we have gone with an OC, and it's a plugin here. Now, only thing is that when you're going with the plugins, you need to see the compatibility with the latest Flutter versions which are coming into market. So for some reasons, if you don't find the compatibility, like your Flutter has already been upgraded but OC is not, and it is causing an issue, I would suggest take a clone of an OC and update it there and use that. There would be an extra dependency there, but that is what would be that is what will keep you going there. Now let's get a deep dive into some of the demo and see some of the code snippets here. Do let me know when you can see my Android Studio. And
yes,
yep. So the very first thing, let's see how many devices is being connected to my laptop here. So you could see here, these are the 2 devices have been connected here. One is one of my emulator here, and one is the real device, which I have connected. So this is how your structure would look like. It's more on like what is the name of the project, hello Flutter, and this would be what is your entire test driver. Let's start looking into the very first thing is pubspec.yaml, where we have added our dependencies. So you could see here that these are the dependencies could have been added, and there are another number of other dependencies. But to get started with, and even though to get started with, you don't need this OZ also. You can just add this and you can get started off with your code base. Now you put Flutter pubget. This is what will give you, it's more like a Gradle or Maven refresh. So it will give you the latest and greatest dependency when you do a Flutter pubget. Now Flutter Doctor, this is what will validate you, like what all has been installed and if everything looks good or not. So by the time Flutter Doctor is running, we could see the structure here that you could apply all the design patterns what you feel, what you have been using in other frameworks, even here for the Flutter also. And you could arrange your test, you could arrange your entire package suites on your screens, like these would be the different screens and how would it look like, and so on and so forth. So it's a sample, so you would not see here that your page object patterns and all. Now, since this is what my integration test.sh file is, if you want to run multiple set of tests in one go, and you don't want to give, so this is what the command is here to run the Flutter driver integration test. Now, if you want to run multiple things in one go and just get what is your result of your smoke, so this is what you will configure in your CI/CD pipeline. We could see here that these is like no issues found, and these are my connected devices. This is my VS Code version, what is my IntelliJ version, and what is my Android Studio, Chrome, Xcode, everything. Or you would get to know. And if you have any issues also with a version compatibility, that also you will see here. So this is what my integration test.sh looks like. Now, to get started, let's also, as we have seen Flutter.com, let's also see Flutter Inspector and how does it looks like. So it's not yet connected, so let's run the test once. And we would see here that how will it look like once we run the test. I feel it's taking longer here. So meanwhile, we will see the test file here, like what is there in my test file. So there are 2 things which you when you get started with. One is you add your dependency in your pubspec.yaml, and then you create this is your e2e ... where your entire app instrumentation happens, and your tests are in your e2e_test.dot. So if you see, if you just see these tests, it's more like you have a group of a smoke test. Now, as we have seen in WebDriver also, we all need a setup. We all need a teardown. And during a setup only, this is where I have initialized the OC. Like to capture the screenshot for all the things under a folder name smoke1. And the teardown is like what it generates your OZ report. We will see once this command gets run here that how the OZ reports are getting coming across. And what does this test do? So the very basic things here. One test is just capturing a screenshot of your home screen, and the other one is just adding your item name and you're adding your label, just trying to figure it out whether you have those two attributes or not. And this app is your sample app, which is present all together. So now it is asking me for the devices which I want to run it. So let me run it on my emulator so I can show you also here that how does it installs and get runs here. And then you could also see that if you want anything further. So this is what we did for my scrolling timeline and all. And here it is more like you are just getting your item name. Now, let's also look into your oz.yaml, where we give some expectation that when do I want my integration test to fail, whether it should fail on warning or whether it should fail on errors, and what would be my performance matrix, what is my frame build rate, and what would be my frame restart and read code. So what is all my thresholds are, and beyond the threshold, it should be. So this would be all being defined in your OZ. Then you add your OZ dependency, and this would be based on your product needs, that what do you want in your oz.yaml. Earlier, as we touched base upon the silk.yaml, also to talk about how you could add your test in and run in your AWS device form. So here is where you will see what all device pools you have available, and based on that you will provide. So like for me it was like one of the Android device, and what would be your timeout of this, and then you will run a set once you configure your AWS with AWS configure. Then you can just run with one command pub global self, and that will run your test in your AWS device forms. So it's still building, it's taking care, it's here. And on a similar note, we do have here E2E underscore test on dark, like for a different end-to-end scenarios. And you could tag them with a smooth, you could tag whatever you need, you could tag them with a regression or any of the categories. Now, where would the OZ goes? That will be defined on your setup and teardown methods, like what would be your path and how would the things would look like. And this is how you would see here that your screenshots are there, and like smoke 1, smoke 2. So this is the one which I just ran this evening before demo here, 1732. And you could see here that this is the entire zip. So for us, it was easy to send this zip across, and then we could get the approvals for auditor, or if there are any changes being needed on that. So you could now see here that this is what it was being captured, like on the screenshots with the timings and what the name I had given. It's like a scenario 2 was the name there to get it captured at that point of time. And now we could see here that the app would be getting installed here, and I feel that my machine is just trying a lot of this profilers and even Microsoft Teams, so many things are open here, so it's taking longer, which would have not been expected this long. Meanwhile, we will also see, I'm not sure whether I'll be able to show you this here. So I was just trying to show you how we could see and debug the .dev tools. Let's see once this goes on, once this runs. Other way parallelly in my terminal. It's not interesting. Let me. Okay, looks like it is. Something is happening. So you could see this is what would be your home screen, and now your this still building here. So you could see that here, whatever the reds, if you see this, notice this red, this is what your frame renders, and whatever you would have given, it's more than that. So you would see whenever you are running your app that the frame rendering will give you those errors. So let me quickly run the performer. So this is where we will see our dev tools, and we will see how does it perform here. Like what is my performance, what are the different CPU profiling as what we were seeing in that screenshot. And if we go back here again, still it is building and it's taking time here. So this is how you could get started. How you can get started with very small, like you just have to add the dependencies. One e2.dart file, one e2e_test.dart file, and you can get started with writing the automation test for your sample for your app. And if this is, yeah, so this has asked me for advice. So yeah, hopefully it will be here in a few seconds. You would see the and that's where it you will, if we go back to the screenshot for the live app, so I'll go back to my presentation, right? And if you go back to the screenshot here, let me stop its slide here. Yeah, but I'm open for any question. Let it run in parallel as we are close to the session, and this is what your Flutter DevTools looks like. We would quickly see one last time if it is it's still taking time here. But yeah, it will be very much similar here. Like you will see your performance, your CPU profiling, your memory, and your networking of your apps. References would be somewhere like you could see, find it out in Flutter Dev community also, and even in I have added some blogs how to get it started, so you could go through those blogs also if that interests you. That's all from my end, and
Okay.
Any questions?
Okay, Varuna, thanks very much. We've got time for a couple of quick questions on Slido. I'll just share the screen. Now, we have 3 questions there, but we've run over the time slot, so I'll just do a couple of questions. So the first question from Uri is, why are you building the parallel world rather than extending existing tools, drivers, dev tools, etc.?
Sorry, I did not get why you're building the parallel world. So It's being existing only the Flutter tools, like what Flutter has came into a picture. And if you are asking on the existing tools on the APM or the APM Flutter driver, so that was the decision we took based on those of the parameters, like what all would be needed for the Flutter. So if that is the question inclining towards.
Okay, and the second final question. I just noted that Aussie Reporter is developed and maintained by BMW. Is that right?
Sorry, I don't remember that. Is it BMW? But yeah, it's a third party. It's not from the Flutter.
Yeah. Okay. So, Varuna, thank you very much for your presentation today. It's been a pleasure having you.
So you should be seeing something now. Why wasn't it tested? All good. All right. So thank you very much for inviting me to this lovely conference. And the topic of my talk is why wasn't this tested? I'm sure that many of us testers have heard this question. Many of us dread this question. And today I'm hoping to give you a kind of an answer to what can we do about things that weren't tested. And the solution that I will be showing to you is code coverage, and I'm going to be doing it with a tool called Cypress. So before we start, I do have a question for you. I'm kind of going to elaborate on what Phil has already asked you, or what you may have been asked on Tesena Fest. And is the question, where are you joining from? But I gave you some options because I'm not really asking about the state where you are, but whether it is actually an office or home office, or you have a bed office. And I'm very curious about how many people are joining from bed. And I was thinking about giving this talk from bed, but I'm not going to do that. Turns out I need to have my camera on for the presentation. So I'm personally at a home office. I am in my bedroom actually, but I am at home, and it seems like it's 50-50 so far. We'll see. Last year definitely put us most of us back to our homes, and we have been adjusting to working from home. But it seems like the transition that everyone is talking about already is already kind of happening. I see it's almost 4 o'clock, and there are half of the audience is in the office. So it seems like we are back. Just a couple of seconds ago, we were talking with Phil about live conferences and meeting again in person. So hopefully that will come soon. And we got some people in the bed office. Those are my folks. Enjoy it, and if you fall asleep, don't worry, don't feel guilty. I'm sure there will be a recording somewhere. All right. If you feel like asking me a question during any time during the presentation, feel free to send it out into Slido. I will be getting to those questions at the end of my presentation. Thank you for the answers. So quick introduction of me. I'm Filip. I work 5 years. I've been working 5 years in Slido, 5.5. And my background is actually in psychology. So I broke into tech in around those 5.5 years, maybe 6 years ago. And I've been so happy to be given the opportunity of working with Slido, where I learned a lot. And some of that I'm going to be sharing with you today. I am also a Cypress ambassador. So I talk about Cypress. I give conference talks, workshops, presentations, webinars, streaming, etc., etc. So that's what I do. And everything can be found on my page, philiphric.com. I am actually not writing Cypress tips every week now because I've been very busy, but I will be getting to that really shortly. In fact, in my to-do list is to write a blog this evening, so hopefully it will get published sometime soon. So make sure you check that out. All right, let's get to the topic. First of all, what is Cypress? If you don't know already, if you are curious, heard a lot of buzz about it, but haven't used the tool, Cypress is a tool for testing anything that runs in the browser. It is completely open source, so you can start using it for free. You don't have to pay for anything, and it's built completely from scratch. So it doesn't use Selenium in the background. It actually uses its own solution. So tests are written in JavaScript or in TypeScript. And there's an interesting design decision with Cypress, because tests are running inside the browser. So Cypress actually opens browser and runs your tests inside them, which gives you a great opportunity to use great debugging tools. So, for example, if you ever use Chrome DevTools, then you kind of know what it is about. And the last point, bullet point on this slide, is actually an interesting design decision. Some people love this, some people hate this, but it is one of the features that causes Cypress tests to be closer to the source code and to the application itself. And it enables you to do things like code coverage. So you may ask, how is Cypress different from Selenium? And this is very often a question that is being asked. I'm not sure I am a fan of this comparison of tools, because it feels like asking how is car different from a motorcycle, which is better? Well, it depends on what is your use case. These are completely different approaches for testing, and Cypress definitely brings some new ideas and some new philosophies to what is end-to-end testing or integration testing. So I borrowed these slides from Gleb Bahmutov, who had a talk on a Selenium conference about Cypress, and the name of his talk was Testing Without Selenium. I mean, what a legend to come with this kind of topic on a Selenium conference. But he explained their architectural difference between Selenium and Cypress. And basically, with Cypress, you write your code in Java or any kind of different language, JavaScript, doesn't matter. It is then processed by Selenium through driver, and the calls from your driver are made to the browser through HTTP request. So you're basically doing HTTP calls to the browser. Broadly speaking, I'm sure I kind of missed a lot of details right there. The Cypress architecture is slightly different. We have a browser, and inside that browser you have two iframes. The first one has your tests, and the second one opens your application. So we get access right into the code. So this actually is the thing that enables you to do things like code coverage. And I really enjoy that feature, because it gives you the insight into what parts of the app you are testing are the weak spots, the spots you haven't looked into. And at this point, I would like to turn to you and ask you, what gives you the confidence when testing your app? Because code coverage is actually can be a part of your strategy, and you can choose different strategies to tackle the quality or the confidence for shipping your app. So if you have an answer, one single or 2 words, or maybe even a short sentence, I would like to ask you, what is the thing that gives you the confidence when testing your app? I'll give you a couple of moments. No failing tests, no bugs from production. Awesome. So you can keep those answers coming. I'm really curious. My goal today is to show you code coverage as something that can give you confidence when testing your app. but also can give you a general idea of what parts of your app are not tested. So we got app business knowledge. Other testers can find obvious bugs, risk and impact focus. Those are all interesting answers. So I guess the risk and impact focus, that would be something that gives you the confidence. Your colleagues, that's awesome. That's a really nice answer. I love that. And the reason why I love that is that I'm really really trying to be aware of like the quality being a whole team effort. So I'm not really a fan of a model where a tester is the gatekeeper who says green or red, but pulling all the team together, developers, testers, designers, and pulling everyone to deliver the quality, I think is the right way to go. Customer satisfaction, that is a good one. I like that as well. All right, so let's move on. Less bugs from production, low priority bugs. Awesome. I'll move on now, and I will be interested in that questions. So let me talk about the code coverage and how does that work, and how does that work in Cypress. So to sum it up, there are 3 simple steps of how it works. You run your end-to-end tests, then you gather information about what functions were called, and then you generate a report. So simple as that. And that is exactly the part that can give you an insight and answer the dreaded question of what is tested and what isn't tested and why it isn't tested. And it can give you an idea of which part of your app is not tested properly. So code coverage is like a map of all the areas you have visited and which you have not and which are yet to be tested. So how to set up code coverage? There are 2 major parts to doing that. The first one is instrumenting your application, and I will explain what that is. The second one is to set up the code coverage plugin, and I will also explain that. So let's jump into the first part. So what is an app instrumentation, you might ask? So instead of lengthy explanations, let me actually show you. So I have my VS Code over here. Let me actually make it a little bigger for you to see. And let's do, yeah. And I'm going to create a new file here. And what I will do is that I will create a function that is going to be called addition. So imagine you have this function in your application, and this application does a very important thing. It has 2 parameters, A and B, and this function will do a simple thing. It will return A plus B. So whenever you call that function, whenever you call this function, it will give you the result, right? So if I do addition and do 1 plus 1, I get the result of 2. So I have this. So let's say I have this function in my test, and I need to know in order to get code coverage, in order to get like the information about whether this function was called, I need to do something with the function. So how do I know this function was actually called? Well, it's actually not hard in principle. What I can do is create a variable, call it an I, and assign it a number 0. And whenever a function is called, I will iterate that number 0 with 1. So if I call this function 3 times, and then I console log out the I, I can see it now has a value of 1. The other time it has value of 2. And again, it has value of 3. So I have changed my function just slightly to get the information about whether this function was actually called or not. Now, doing this manually, of course, doesn't work, but we can we can tap into the build process, which is part of, I would argue, every major web application nowadays. And we can use those processes to work for us and to instrument our app. So when a web app is built, we use different kinds of tools. So there are Webpack, you probably heard about that, Rollup, Vite, Browserify, and all those tools actually have a common goal. They take all of the files that are used to create our application, so all the components and functionalities and modules and everything, and they export that to, usually it's a dist folder or something like that, to create a bundle that a browser can read. So browser cannot read something like require or import. That is actually, you need to reference your script file into your HTML file. And these tools over here automate the creation of the production version of the app so the browser can read that. So let me give you an example. For example, Browserify here. It takes the app.js file and it creates a bundle. So this -o is create an output. So the Browserify looks into the app.js. It looks into all of the imports and exports and all of the links and everything, and creates a one giant bundle.js file, which is then imported into a main or index.html file and is referenced there, and your application is now working. So moreover, we can customize the code that is being generated. So additionally to those Webpack and Vite and Rollup and all of those other tools, we can use different plugins. During the process of creating that final bundle, we can actually transform the code. So we got tools like Babel or Uglify.js, which can do different things. So for example, we can ensure compatibility with Internet Explorer with these tools. We can minify or uglify our code so that we take all of the variable names and function names and minify them to single or double letter functions, which we as people don't need to read, but we can decrease the whole bundle file, and our browser doesn't have a problem reading that and can execute the code well. But if we have a giant application, we can minify that and make it smaller. Or what they can do for us, they can do our code transformation or the instrumentation that I mentioned. So what they can do is to transform our code on the left and create a code on the right, broadly speaking. So the approach of how you do this instrumentation might slightly vary on the framework you are using. But in Browserify, what we would do is to add this Babelify, which is a plugin into the whole thing, and it will, with proper plugins, it will create an output bundle which is instrumented. So it will create, so from this function, it will become this function where we can actually have those counters and see the function being called. So this is an app of my own. It is a Trello clone app, and it's actually on my GitHub, so you can download it and play with that. It is actually instrumented, and you can look into how I did that instrumentation. But I did it using a tool called Istanbul. So it is exactly the middle part of the of the whole process, which transforms my code. And what it does, it actually adds this coverage object into the window context. And this coverage object has all of my files, all of the components that make the app referenced, and it has also like a map of what functions are there and how many times they have been called. So this is something that that is live updated. So when I interact with my application, the coverage object actually changes and counts every function as it is being called. So when we have our code instrumented, then we get to the easy part. Then we get to just setting up the code coverage plugin, which is, if you have ever experienced working with Cypress, it is a very easy process. So usually you have to install a plugin and then do a couple of imports. So there's support index.js file, you import the plugin there, and there's also plugins index.js file where you would import a task that actually is responsible for generating a report for your code coverage. All right, that was kind of hard for me to say. All right, so let's go to the demo. Let's show you something. We'll close this example over here, and I have my application over here. And as I mentioned, you can look into it on my GitHub, and I will show you the link at the end. So what I will do is I will start my application by typing npm start. And it is actually an application built in TypeScript, built with Vite and in a framework called Vue.js. So it's kind of my experimental place where I like to play with creating an application. It's a lot of fun and it's a lot of bugs, so you can check that out. Another part is Cypress Open. So let me actually open Cypress. And I have a test over here, which I'm now going to run. And let's make it bigger for you so you can see that. Oh, that's maybe too much. All right. So in my test, what I did is that I opened my application. So if you are familiar with the Trello app, it's basically a to-do app, but you can add your to-do lists. You can create a multiple to-do list and then add them all into a board. So to create a board, I will do new board. And here I have a list, and here I have a card, which would basically be my to-do, right? So I can check it off or something like that. So let's now focus on creating a new board. Before I do that, I'm actually going to run my test again. And you can see that there are before hooks and after hooks in my test. And these are basically what they are doing. They are resetting the code coverage before the test starts, and then are generating the report after the test is done. So let's actually look into our report. How much have we covered just by opening the application? So this new board, this doesn't count. I'm actually going to delete it, run my test again, and I will show you my test. Let's show you the tests. And yeah, so the test is nothing. The test is just a single command visiting our application. And inside the coverage report, I can see that just by opening my app, I have covered 30% of the application. So that's pretty neat. End-to-end tests can cover quite a big part of the application. If I were trying to do that with a unit test, it would probably take a little more time than this. So so let's actually, what we can do, let's look into a component in my application. I will look into the board create. So this is a component that is responsible for creating the board. So it's actually this one, right? So I click on it, I type in my text, and I create a board. And that's the whole, that's everything that the component does. So right now I can see inside the report, actually make it bigger. Inside the report, I can see which of the functions have been called on and which haven't. So let's, I have a couple of methods over here, and there's a create new board method, which probably creates a new board. So let's do that. I am going to write a test over here. So let's select my element. I'm going to use selector playground, because why not? And I'm going to click on this element. Let's click on it. And after I click on it, there is an input field which I want to type in. So let's select that. I'm going to copy the selector and get my input, type into it, and I'm just going to write a new board and then hit enter. So I'll wrap this in the curly brackets. So when I do that and run my test, I have the coverage report is generated. So let's look into our report. Let's refresh that. And I can see that there are already a couple of functions being called. So there was this toggle new board input, which I toggled. So that was called. I created a new board, and I also called an HTTP request over here. And when I did that, that's what happened. All right. So, but I can see that there's also a catch over here, which if there's an error, it will actually show a notification that my board was not, it was not possible to create it. So let's write a test for that. I'm going to create another it block over here and do fails to create a board. And this is actually super fun to do in Cypress because I get to use the intercept command, which is looking for HTTP requests that are happening during my application. And not only that, I can actually change the response and simulate different conditions. So when I look over here through the timeline, I can see that there's a post API boards HTTP call being done right after I click on that create button, or rather right after I hit enter. So I'm going to match this one. So it's a post request. The URL is API boards. And the third argument is actually an object that will handle the response. So I'm actually mocking the server. And let's do force network error. And I'm going to give that true. And the rest of the test, let's just copy that. So let's now run my test. Actually, both of my tests. So the first one will create a board and the second one will fail. The notification is here. And yeah, so I basically simulated a condition where I would have a network error. So let's look into our code coverage and see if we have actually caught this catch over here. And yeah, we're done. That's great. So let's cover one more thing. And I can see that there is an if statement. So I'm supposed to write a board title inside the input. But if I don't do that, I should actually return. The function should not do anything. So this is a spot I have not covered. I did try to create a board. I did try to create a network error. But what I didn't do is try to just open the input and hit enter and see what happens. So that's something I have not yet covered. So how about we cover that? And there's also a thing where if I if I start typing and click away, it should remove the text. So that's also something that's not covered, right? So if I click away, then the new board title should go back to empty. So let's do that. Let's call this test cancels creating a board. And what I will do is, let's actually copy this. So I will visit my page, I will click on the create board, and but instead of typing in the text, let's copy this also. Let's instead of typing the board, let's hit just enter and see what happens. Now, when I save my test, they're automatically rerun. So the first one, second one, third one, awesome. And let's look into our coverage, and I can see that I have covered this. So this is awesome. And let's also try to click away. So I will just add to my test. Let's click on that create board again, because it will close after I hit enter. And then I'm going to just click on the root, just to click away somewhere. So it's going to just click on the middle of the page. Hopefully nothing is on there. There actually will be something on there, I guess. Yeah, I accidentally opened the board. When I look into the timeline and see the root, just click on the middle of the page, and you can see that it has actually clicked over here. So let me remove all of the boards and run the test again. And I would definitely write this test in a different manner. Just wanted to do a quick demonstration over here. And now I added the test to click away and see that the method is covered. So great, I have written almost 100% coverage for my test. But you may have noticed that I didn't write a single assertion here. So as I said, so here I have a method on click away, and if I click away, then the input should be empty, right? And luckily it is, but if it wouldn't be, I didn't find out, right? So so the QA part and looking into the code are not the same thing. You still need to use your tester brain to analyze the application and to make sure that it not only works, it is not only covered 100%, but it also works as intended. So yay, we got the 100% coverage, but I would advise caution with code coverage. As I said, we do not have a single assertion in those tests, and yet we have covered a pretty big part of our component. But we don't know if, for example, different types or different input types would break our application. We also cannot be sure if we are bringing value to our customers. So I know we hate the question about why wasn't it tested? And code coverage can be a great map of finding out what is not tested. But when we asked why it wasn't tested and we feel guilty, let's make sure it doesn't pop up also with 100% coverage. So we're still, I think the testers are still great. You're all doing a great job. And the greatest tool you have at your disposal is your mind. Don't forget about that, and make sure to keep 100% coverage not as a holy grail of testing if you are interested in implementing it, but keep the eye on the customer. With that, I would like to thank you, and if there are any questions, I would be happy to answer them. Before that, let's stay in touch. As I said, I have my blog, and you can find me on YouTube, Discord, Twitter, LinkedIn, Twitch, GitHub. And to find me, just put a slash after my name, filiphric.com, and I'd be happy to be in touch with you.
How to present this technical view of coverage to product owner or business users. To cover the code does not mean it works properly business-wise, right?
That's right. So I don't know how to answer that question. This is a technical view, and it can give you some confidence, but I would argue that it shouldn't be a solo tool for you. So if you have business priorities, then make sure you properly match that with the technical side of things. So yeah, I guess that would be my answer.
Okay, so it's an addition to your toolbox, not a replacement of your existing approaches, I guess. Yeah.
Yeah.
The second question from Jana is how, and this is, I was interested as well. How do you use the results of these tests as a tester? You write some tests, you run the test, you check the code coverage, and you say, okay, low coverage. What does that mean? What do you do next when you see the results?
Currently, I don't have like a threshold where I want to go, or a threshold which I don't want to fall below. So it's just like an information for me. And the biggest value for me as a tester is, okay, to look at the code and see which parts are not covered at all. So that's pretty valuable for me, and it answers the question, okay, what should I write a test for next? And definitely priority number one is, like, of course, the business side of things. So which are the most crucial parts, and that even probably may deserve 100% coverage on top of like the main user stories. But yeah. But you can definitely set up a threshold. There are tools for that. I think Coveralls works, and there's a code COV tool, and this is a great one for like having that threshold and keeping an eye on that, and even making your test fail. I think if the coverage is not enough.
Okay, and if I could add my own question, yeah, I've written some tests based on the user story, based on my acceptance criteria, and I've checked the results of the code coverage, and I see 50% covered. Yeah, mm-hmm. So that's 50% of the code I didn't run in my tests. My reaction is it my problem, or is it redundant code in the application, or is it bad? It could actually be bad coding, no, or just like somebody forgot to delete some redundant code from the source.
Could be, but without consulting the developer that wrote the code, I wouldn't have the answer for that question. But that's a great conversation starter with a developer. Okay, so what is this? What does it handle? Do we need this? Should we cover that? Can it break something? Those are like awesome questions to ask and work as a team to bring that quality.
Yeah. Okay.
And maybe that might even be the answer. Maybe that might even be the answer for the question before, like how to approach this technical view and explain that to the business side of thing, like the product owner. So we got all our scenarios covered, but look, 50% of the code is still not covered. Maybe that may break something. I don't know, just guessing.
As a guy who came a long time ago from development, that sort of feedback would be excellent for a developer. I think, I've got this code here and it does nothing. What's it doing there? And somebody has to read it and maybe try and maintain it for no reason, whatever. Yeah? So anyway, the next question.
The developer will be happy to delete that.
yeah. I think these days, yeah. So next question from David. Oh, I think this is okay. I know you don't like the comparison of Cypress IO versus Selenium. What about Playwright? Did you try the tool already? Any opinion?
I did. I did try it. I did not do analysis of the tool, so I'm not able to answer the question with like in a way that my opinion on that would matter. With the short time I spent with Playwright, I think I would argue that Cypress has a much better developer experience. Like it's very easy to get up and running with Cypress. You can do that in a couple of minutes, and you can even write a couple of tests in a very short time, which is awesome if you are just starting to build up your test automation suite. I think Cypress is faster in that regard, but that's my opinion. Probably someone else would find Playwright more suitable for them. I don't know. That's my experience. Hope that answers the questions at least partially.
Okay, thank you. And one more. Oh, I think we could probably do 2 more questions if you don't mind. Again, David, could you generate the tests from code to achieve a certain coverage?
Generate tests from code? I haven't heard of that. Not sure how that would work. I'd probably lean more towards no, but yeah, I don't know.
Okay, and jumping to the next question, our favorite attendee, David Christ, he was very, very active on the questions and feedback. Can code coverage results be also seen in Cypress dashboard?
No, they cannot. Not as at this day. But I think, I don't know, maybe they will be interested in adding that. It would be a killer feature in the Cypress dashboard. They do have a great analytics over there. So I think giving the code coverage might be a great addition. I'll talk to them, see if they are doing anything on that part.
Okay, and the very last question from Roman. What are the generic assertions you would recommend besides coverage?
Not sure if I understand the term generic assertions. If you mean like asserting the state of your application in like a different way than using the test automation, then I think the visual testing might be a great addition. Or component testing, maybe. If you ever use Storybook and stuff like that, I think that might be a good one. But I'm not sure about the term generic assertion. So, but visual testing is a good addition to like the whole test suite. But it also comes at some maintenance costs, so that needs consideration there.
Okay, so Filip, thank you very much. As always, a great pleasure. Always very interesting. I really do like your talks, and I'm non-technical, but I sort of get it. So I'm very happy, and I like Cypress. I mean, as you said, if you're starting out, I think Cypress could be a great confidence booster. Yeah, because otherwise it seems intimidating, overwhelming. Yeah, and with Cypress, as you said, I did test automations, university's JavaScript pillow, whatever you call it, and I like the JavaScript at the beginning with the evil tester. I thought that was great, and then we jump into Mocha, and then we jump into some chai assertions, and then bang, I've written my first test in Cypress. Yeah, and it was a few days over a holiday period, and I felt like a test automation engineer, which of course I'm not, but I would say definitely if you're interested in starting out in test automation, I would strongly recommend starting with Cypress. Yeah, it's a good place.
It definitely has been that experience for me. Like my test automation journey is actually my Cypress journey, and I learned a lot about JavaScript. And the early satisfaction you get from writing your first test, that is a great booster that can keep you going. So I definitely agree with that.
Okay, so Filip, thank you very much once again.
All right. Okay, so I'm talking to you here today about integration testing with Docker and with test containers, and a little bit about myself that gives you a bit of context. So I'm not a tester, and I don't have a tester background as a software tester. I'm a software engineer, always have been a software engineer and been working as a software engineer, but still I'm testing because, so I'm a developer, yeah? Developers need to test as well. And I hope what I can tell you or show you today will be helpful for you as testers, or if you are developers that are also doing testing, it will be helpful. Or if you are a tester only testing, it's something you can also show to your developers and say like, oh, let's introduce this, that both parties can benefit from this. and I'm working at the software company Atomic Jar, which has been founded this year and which is, so to say, we call it now the Testcontainers company, because it is the company also mainly responsible now for maintaining the Testcontainers open source project. What is Testcontainers? We will talk about this a bit more in detail soon. And I just come back from a 2-year break in academia. So I jumped back from industry into the academia, where I was leading a blockchain research lab. So I was doing completely different stuff. And officially, I'm still a PhD student, actually, and doing my PhD blockchain related stuff. But there will be no blockchain today whatsoever. I'm also doing some activities on my own as coach and trainer for topics such as testing, test-driven development, and so on. And I'm one of the maintainers of the Testcontainers open source project and Oracle Groundbreaker ambassador. Okay, so I probably don't need to ask you why you test, because especially if you are QA folks or if you are testers, then this is your job and you do it to improve the quality of the product, probably, of the software that is being developed. I personally, as a developer, also I test a lot because it improves the speed at which I can develop. It gives me a much faster feedback cycle, ideally if I have good tests. So I have been a TDD fan for a long time, and TDD you of course do with unit tests a lot. But the way we have to develop software nowadays changed a bit. So we have more like microservices, we have more cloud stuff. In general, our software integrates with more components, and that's why integration tests become more important. And nothing is more painful for me than kind of blindly developing against some external component, then pushing it and seeing in the CI pipeline or whatever if it finally works or not. So I want to be able to know if my code works while I'm writing it, basically. And in addition, we should be in a place where if a new developer, or it could also be a new tester or whatever, it doesn't matter. If a new a person joins a team, they should be able to directly get started, like clone the project, build the project, and that's all. And it should directly run the tests, run the integration tests, without having to manually configure a lot of things, to manually configure the environment, installing databases, configuring databases, etc. That is not a modern way. We are doing those infrastructure as code approaches, the DevOps stuff, the GitOps stuff. This should also be part of our test suite. So the test suite should be able to bootstrap its test environment. So I believe this is a good practice that we should follow in open source projects, but also in enterprise projects. And especially in open source projects, it's very important if you want to have people like seeing the project, just wanting to contributing maybe something, a pull request, if they have to follow long setups to even get the project running, get the project building and testing, that's very demotivating. It's not a good way to start. So a good project, you clone it, you can build it, and it will also automatically run the tests without any manual setup required. And I will talk about integration tests, and I know different people have very different definitions of integration tests, and testers probably again different definitions than developers, I would think. We as developers, or I as a developer, and many of my colleagues, when we think about integration tests, yes, we have this classical test pyramid in mind. At the bottom we have the unit test, and then above this, like these, they already have different names. Yes, the middle layer, but those we call generally integration tests, and then above maybe UI tests. Sometimes they are called end-to-end tests and so on. So the definitions are very, very unclear. But what I want to call integration tests, also in the context of this talk and what we're looking at, are those tests that interact with external systems, external dependencies, most of the time external processes. So if I'm having a test that will, for example, if I'm in the Java world, it has to launch my whole application server, like the JBoss or whatever. This is something I would consider an integration test, because it's integrating against this whole application server structure. When I'm integrating against bigger frameworks, like if we have something like Spring in mind, for example, Spring Boot test is a special test annotation in Spring Boot. And these are all integration tests for me because they spin up the whole application context. And then the very classic examples are those interacting with external processes, often over the wire, over the network, or with the file system maybe, and then like such things as databases, for example. Yes, the database is a prime example for integration test if you test against the real database. But we have many other components nowadays against which we integration test, like a Kafka, event bus, whatever, all kind of things. And yes, so we have this pyramid, which is even not that old, though it has been circulating in the industry, also especially originating in the agile industry since the beginning of this how you call it, it's not century, millennia, yes, so since the 2000s. And Mike Cohn is one of the first people mentioning it, but it's not a bit more complex, who was maybe the first person. Still, why is it a pyramid? Because we considered for a long time that the integration tests are hard to write, hard to maintain, slow to operate, and therefore generally people say it's better to have many unit tests and then just fewer integration tests. And then the end-to-end tests become even harder to maintain and to run. But this is probably not that correct anymore nowadays, considering many technologies and many code bases. And that's why we see, especially in companies that going more in the microservice road, this testing honeycomb, we can call it, some call it testing diamond, etc. And this is from a blog post from Spotify. And again, they give different names for these things here, yes? So here, implementation detail is the unit test. And then the integration test is the main stuff they use for testing their microservice. And then they have here another concept, integrated test. And I like this concept of integrated test very much because it's a way to distinguish from the nice integration test. And what do they mean with integrated test? This is from a blog post from JB Reinsberger and from the TDD community. And he says, I use the term integrated test to mean any test whose result, pass or fail, depends on the correctness of the implementation of more than one piece of non-trivial behavior. That's really nice, long definition. And Spotify and the blog post rephrases this as a test that will pass or fail based on the correctness of another system and also of the correctness of another system state. And if we think about examples for integrated tests, so these are anti-patterns. Yes, we don't want them, we want to minimize them. And examples for those integrated tests are already if we have to have a locally running service that has to be in a certain state. We have to manually put it in a state, or it is a service running somewhere else. Yeah, but my test suite will fail if I forgot to run the service before the test suite runs. It will fail if I configured it wrongly. It will fail if this is a stateful environment that hasn't been cleaned up against after the tests, for example. Yeah, so these are all anti-patterns. We want to avoid those very much because they take away the confidence into our test suite. Because very often then what happens, the tests fail, but then we look at them and we think like, oh yeah, this test is all the time fails because someone from the other team again did the migration against the shared database, whatever. Like those kind of things happen. You become blind against the real test failures, and you don't trust your test suite anymore, and it becomes just noisy. Yes, so we want to avoid those. Here, another example I have here: testing against other services in a shared testing environment. Those kind of big host databases, for example, that are shared between many teams. In some environments, we have those kind of setups, and that's not good. That's not nice. And it's not good for testers. It's obviously not good. I assume I'm not a tester, but also for developers, it's terrible because it gives you very bad feedback cycles while developing. So what do we use to avoid these, having those integrated tests, those anti-patterns that arise because environments are not in the state they are supposed to be, or because environments are shared between different parties? And yes, we can say that Docker and the container technologies allowed us to use a new pattern to do this more efficiently as it was possible before. Because, and I don't want to go into too much detail about Docker, although I don't know who of you knows Docker, who is it already using. So I will just give a quick overview. So yeah, okay, Docker containers. people say like, oh, they are similar to virtual machines, but actually they are of course not, because as opposed to the virtual machine, the containers all share the same kernel, which makes them very lightweight, and we can have many different containers running on the same kernel. And compared to a virtual machine, it's very cheap to create containers and to start containers, remove them, etc. And we have a very nice API in the form of Docker to instrument those containers. So here we see the difference between container and virtual machine. The virtual machines all have guest operating systems and containers not. They have the shared host operating system. Therefore, it's Docker containers are a very good way to automatically in an infrastructure as code way spin up test environments on demand. And of course, this was already and is still possible with virtual machines. And we know Vagrant is an example where they did it with virtual machines. Just virtual machines were much heavier. It was much more expensive to do it with those. And therefore, the feedback cycles were worse. All right. So now, why do we bring the container world now into the testing world, into our code base? Yeah. So now I say we want to have an easy setup of a dev environment, because for me as a developer that uses tests during development, the test environment is part of my development environment, yes? And then I want to have a way to describe those environments, the testing environments and my development environments, that will be uniform in all stages of my CI pipeline, or whatever, in all stages where the application will be built and tested. And what do I mean with this? For example, if we are using a CI system such as GitLab CI or all the others, yes, where you define your CI pipeline with the YAML files, very often you can define also containers in those YAML files as components you need during certain stages of your build for your integration tests, for example. But if you do it like this, you now have two different ways to set up your test environment. Like one way would be in CI, the CI system sets it up for you, and the other is locally with whatever you're using locally. So that's not nice. We want to have a mechanism that we can just transfer into every environment, and it uses the same mechanism to always sets up a uniform environment against we can then test. And through this mechanism and this infrastructure as code, we reach a point where ideally, we don't have to install any external software to build and test our application. But of course, yes, Docker will be required, or whatever other tools will also be required, but not following those Wikipedia pages of database installation instructions we might know from other former projects in which we have been. So now, how do we bring those together, our development world and the container world? And in case of Java, yes, it's test containers. So what is test containers? So this is how you use test containers. Yes. So test containers is a Java library, is a Java API, object-oriented API to describe and instrument containers. In this case, we see, okay, here we want to have some kind of container. So the class is generic container, and then we just specify the Docker image like always, and then we can specify other properties of the container. Then we can start it, we can then test against it, then we can stop it. Yeah? So this we can do as part of our test. Before our test run, we start our component, then we turn it off again. Now, what is important in this example already, the start, running start here will be a blocking call that will actually wait until the application in the container is ready. And this is different to what Docker provides to you. If you are using Docker directly, so we could have the same command more or less. If we would run it in Docker, it would be Docker run Redis, whatever, yes? And then container gets created, container gets started. But Docker run directly returns, because Docker is just concerned with starting containers, yes? It's the container process. So it would directly return. And then if we would want to test against this container, then maybe it would not work because the application inside the container would not be ready. And test containers is or can be aware and can be configured to be aware of the applications running in the container to wait until they are really ready and ready to be interacted with as part of our tests. So in this very simple example, by convention, test containers would wait until the TCP port 6397 is reachable and a connection can be made to this port. And in case of Redis, this is enough. So if Redis opens this port, then you can start interacting with it. And that works very well. Okay, so someone knocked at the door, but I will not open. I will go on with the presentation here. All right, so this brought me a little bit out of my flow. Okay, let's just go on. This is like the basic vanilla API. Yes, object-oriented API for Docker. Now even they're ringing the door. Oh my God. So a little bit about the project, background about the project. So Testcontainers Java. Java is the main library. It was first released in 2015 by this guy here, Richard North. Is an open source library, 100% open source under MIT license. And yeah, we have many releases by now, 65, even more, maybe many contributors. So it has a really lively community. It's used in a lot of Java projects, certainly the Java ecosystem. And we have 3 core maintainers in our project. It's Richard, then we have Sergey and me. And we also have some forks and re-implementation in other languages like Python, C# and many others. But the Java one is the official one, the core one. There's also no code shared between those different libraries. Yes, so they try to align with each other, but they are their own thing, so to say. Okay. So you're just like seeing is just a nice metric of a popularity maybe of open source project. So over 5,000 stars, it's quite good for a Java project, so to say. Yes, I know probably before you had other talks here about Cypress, they will have many more stars. I think like JavaScript projects have many more stars in general, but for Java projects, that's not bad. And some of the features test containers provide. So we saw already the code example for generic container support. So everything you have a Docker image for, you can instrument with test containers to test against it. Then we have also special support for databases, relational databases, for example, and systems like stream processing systems, something like Apache Kafka, Apache Pulsar. And those modules just will give you some more convenient functions like special methods to directly get a JDBC URL or whatever. Support for the mock containers of the cloud vendors. So if you want to test against those cloud services, they provide you mock applications so that you can then still test against them over the wire with the official clients. We have support for those. Then if you are already using Docker Compose, maybe to set up your environment, you can use your existing Docker Compose configuration. But it's basically also possible to use Docker Compose, to use test containers to replace Docker Compose altogether, because you can describe the same environment just using the primitives of test containers directly. And yeah, special support for Selenium, which you can but also use with other, like we heard Cypress before, you should be able to use those modules also with Cypress. Basically, it is for running the browsers in a Docker container, more or less in a headless way. And nice support for chaos testing with Toxi Proxy that you can simulate dropping packages between containers and so on. Some of the generic features are, yeah, I already mentioned the wait strategy. So test containers is waiting until the application inside the container is ready. This is the wait strategies. And the simple one is using just a network port, but there can be more complex ones. Like, for example, waiting for a certain log message to appear, or waiting for a JDBC interaction, a JDBC request to return something so that the database is ready, whatever. Then another quite important thing is that we don't bind to fixed ports. So very often, if you're if you're starting a Docker container, you say, okay, I want, I don't know, my Apache Tomcat should bind 8080 to 8080. And that's not how test containers works. So test containers will use the publishing feature of Docker to just publish port 8080. Then you get automatically a free port. That's a Docker feature. It will be an ephemeral port normally, so something about 60,000. And then Testcontainers provides an API that gives you the actual port after the container has started. This port you then just inject in your system under test, and this allows you to make your test resilient to run in all kind of environments, because you don't need to be aware which ports, for example, are free. It also means you can directly parallelize your tests, because then they will not have port collisions. They will just start containers on different ports. It works on all operating systems and also in all different Docker configurations, so support for Docker machine, for example, or Docker host environment variable. But then, of course, also the Docker desktop distributions, meaning Docker for Mac, Docker for Windows. And yes, all platforms, also on Linux, of course, natively, and also using the protocols, the Docker connection protocols that are provided on those environments. Yes, so on Linux and Mac, we have Unix sockets, of course, while on Windows, we have named pipes. It works in all major CI systems and even in non-major ones, probably. So I never discovered, or we never discovered a CI system in which it was not possible to get test containers working. And yes, we're using GitHub Actions internally in test containers, but we were using Travis CI for a long time, Circle CI as well. And yes, our users, all kind of CI systems they are using. So beside the direct API I showed before, we also have special integration into test libraries. This is the JUnit 4 integration, which was the very first one. You can then use JUnit rules. So it's a class rule or rule. This will automatically start and stop the container before each test method or before each test class. So class rule is for each class and rule is for each method. And those this is how the test framework integrations generally work. But of course, you should be aware starting and stopping container for each test method, that still becomes expensive. Not as expensive as a virtual machine, obviously, but still, it's not starting a Postgres container is not for free. Yeah, if some of you know Spock is a testing framework also for the JVM. Works like this. You are annotating your class with test containers, and then the container fields get automatically instrumented by the extension. And the JUnit 5 extension looks very similar. So all the containers you have defined in your test class, they get automatically started and stopped. Cool. And now it's time for some demo, finally. So for this, let me switch to my another screen. So if you so if you want to, and if you can't see, I don't know, can you see? Is it big enough? I don't have a channel to use, so I don't know if you.
I
yes?
can see it, but it's small.
Okay, let me cool. Let me just enter presentation mode. That should be better.
Now we can see it.
Okay, then hello back. Sorry for the small glitch. So I'm having here a Java project, and I'm using Gradle as a build system. And if you want to get started with test containers, all you need to do is have the dependency. So the Java dependency. You don't have to install anything. Yes, just use it as any other Java library. So in this case, I'm using this BOM bill of materials. You don't have to use it like this. You can also directly specify the dependency. It's just then I can use all the different test containers modules here. I have Postgres, Kafka, Jupyter without specifying the version here. Yes, and now I have here a very simple example project that doesn't do anything useful really. So I have a book class just with two fields, name and author, and I want to save this in a relational database. So for this, I have a book repository class, and this is just using directly Java SQL code to interact with the database. Yeah, so this actual implementation is not really important. And I don't want to use any framework to just show, okay, that's how you can directly use test containers. All right, then I have here another class, and this is just for sending messages to a Kafka. Yeah. does nothing useful really, just send messages to the Kafka. And now we want to integration test. So we want to integration test our book repository class so that it interacts correctly with our relational database. And we want to test the special offer notifier class that it sends out those notifications to the Kafka topic. And okay, then we have this class here. I'm now using the JUnit 5 integration, so the JUnit Jupyter extension. That's why the class is annotated with @Testcontainers. And now I have a field here in my JUnit test, is Postgres container. Okay, this is one of the special modules. And by annotating this with @container, it will automatically now be started and stopped before and after each test method I have here. And I have some simple test methods. So checking an empty repository is empty, and I can also save some books, and I can save multiple books, and then ultimately I can search for those books by the author. Yes, cool. So let's just run this. And I'm just running it from the IDE. I could also run it from the command line and so on. Doesn't matter. I have nothing running in the background, no database or whatsoever. I'm just running my test now using Gradle in this case over the IDE. And yes, so we see already here some output connected to Docker. So now maybe you didn't see now that the test worked. So I will run the test again. So as you can see now, we see some logs here from Postgres. So it is creating a container automatically for the first test. It creates a container. Then the test runs again. Now for the second test, it does as well. And so it does for the third test. And now in total, it takes some time, of course. Yes, so 18 seconds. That's not really fast for 3 tests. Then again, considering that we are 3 times recreating a database, and we are not only recreating like the database on a logical level, no, the whole database container we are recreating, and the test is like the test time is okay, yes, but still we could and should make it faster. And one approach to do so is to at least use the same container between all tests. And if I make this now here static, this indicates that this container should be reused for all tests in this class. And now instead of before each, I just do before. Okay. And now what I want to do to avoid test pollution, just between all the tests, I will just clean the database. Flyway is a tool for running database migration. So I'm cleaning the database and then I'm applying the migration again. And we saw here it was 18 seconds. And if I run it now again, it will hopefully be a bit faster. First of all, I did, oh, this has to be static, of course, no? Oh, before each, I think is the annotation, sorry. Before each, yes. And then not static. Okay, and now we are in the milliseconds per test, yes? So with this we can live, I think. And that's something we also generally recommend when using test containers, only because now it's easy to get a new container for each test doesn't mean you should also do it, because it's still more or less an expensive operation. So don't solve test pollution on the infrastructure level, better solve it on the logical level. Logical level, like for example, recreating the schema, cleaning up the schema, whatever. And the Kafka test, just a similar approach. So we have here a special Kafka container and yeah, same integration. And if we run this, which I will do now, it will maybe take a bit longer because I might need to pull the image, which it also does automatically using the, yes, you see, now it's pulling the image because I didn't have the Kafka image yet on my machine. So it's pulling it now from the Docker Hub and then will work. So, and by the way, side note, why did it crash before? Because here's this sharing window from, I don't know, Microsoft Teams. And I moved this to the side. And once I moved it out of this context of this window, it crashed all the time. Yeah, so that was my mistake, it seems, but it's a bug in Microsoft Teams. Okay, now it took some seconds to pull the image, which of course only has to be done once. If it's on the machine, it doesn't have to pull it again unless it has changed. And now it's spinning up the Kafka and like a small one-node Kafka cluster, also with a zookeeper included, and you can run the integration test against it. And as you see, basically from a clean state now, after 1 minute, it finished the integration test against the Kafka, including setting up the Kafka. And if I run it again, just to show you the influence or the impact of the image pulling, was probably 30 seconds or something, we might finish the test much faster, 11 seconds, which is good, I think. All right. And to maybe finish up the demo with the last example. So we now saw something which I call in-process testing, because we are testing from our application, the integration with our outside collaborators. But we can also use test containers in out-of-process testing scenarios. And now I'm using a Docker Compose file to define the application against which I'm testing. And we have different services. We have 2 different front ends against which we test. One is built in Python. One is built in, I don't know, even I think in JavaScript. And then I have a back end that synchronizes something between 2 databases. So a Redis database, in-memory database, and a real Postgres database. So it's a quite bigger system, like in microservice architecture. And now we want to do an out-of-process test, a browser test against this. So instrument a browser to interact with our different websites here. And I wrote here a test using Groovy this time, so also another JVM language, a JEP test. So I'm not going into JEP, but JEP is kind of a DSL for Selenium. And now what I'm doing here is I'm defining a test containers Docker Compose container, which I can just point at this Docker Compose file I had already. And then I'm creating another container here, a browser WebDriver container. This will start a container with a browser defined by the capabilities for the WebDriver. And then I can get the WebDriver, and using the WebDriver, I can do my Selenium test. And in addition, this is kind of a nice feature. I'm enabling recording mode, so it will record the test session using VNC. Then we get a video of what is happening. Okay, and yeah, the setup part we can skip, but it's more or less just connecting them in the same network, Docker network. And then here, these are our tests. So these are JEP tests now. So first I visit the vote page. I check that certain things are displayed there. Then I visit the result page. Because this is an application for voting between 2 choices. Yes, so this is the example application. I would show this more if it would be a bit more convenient for me here to switch between the windows. But since I always have to stop the sharing and it was kind of glitchy before, I don't want to do this now. So back to the test. First, we visit the vote page. We check, okay, there are 2 different votes I can have, Groovy or Kotlin. Then we visit the result page, and these are all executed in order. Yeah? I visit the result page. First, the result is 50-50 because no one has voted yet. Then we visit again the vote page, and we click on a button, and then we see that the result has changed accordingly. And now I will run this. Okay. We can also, at the same time, in the terminal, check Docker PS. Okay, again. Running at the moment. Okay, now we see already that all those different applications, all those different containers have been started by test containers automatically, like the front ends and so on. Okay, and yep, so the test is passing, everything worked as expected. And now we can check the video just for fun. It will be output here. Open in Explorer. So here is now the video recording. Okay, and this was a test that was running in the container. Yes, sorry, it's probably now small for you and you couldn't see, but for whatever reason, whenever I'm now trying here to share Windows, the browser crashes and then I have to relog into Microsoft Teams. Not sure what they are doing here. Okay, cool. Now I have to ask how much time I have left.
We've slightly overrun, but if you have just a couple more minutes, I think we can keep going.
No, all good, all good. I will just, because everything is now also gone, the slide and so on. All is good. We can go into the questions.
Yes, we have several.
Yes.
Anyway, first of all, thank you very much. That was interesting and good recovery from the technical problems.
Yeah, I'm very sorry. I tried my best, but therefore I also wasn't able to like freely switch between the different windows and yeah.
Okay, so the first question from Peter: any experience of usage on an enterprise level, for example, a bank, simulating more complex environments, both integration and data?
Yes, so that's definitely possible, and I would say like so enterprise level is often nowadays simpler than cloud infrastructures. So in general, those kind of infrastructures, you have a good chance to be able to do this. What you should keep in mind that you, especially when you do it as part of the in-process testing against the outside integration points, you don't need to set up the whole environment. You instantiate the classes that interact with those outside dependencies and the outside dependencies that are part of this test you instantiate. You don't have to do like the real Kubernetes cluster or whatever, yes? So try to slice it down to the test context you need for this test. However, if you really want to have a bigger system test, end-to-end test, this is also possible, but at the moment only as long as you start containers that are still being able to run on the single machine and on which you have Docker running. So if you need the really big Kubernetes cluster, then it becomes more complex. With regards to data, that is definitely also possible. The question is how you get the data set up. So if it's terabytes of data, for example, how you get them set up. Putting the terabytes of data into the containers after the containers have started, this takes time, but you can do it. The other way is sometimes you can just mount the files to the correct location, depending on how the data is used in the containers, yes, in the applications. Or what you can also do, you can bake the test data into the images and then use directly those specific images for your tests that have the test data set up. Now, if the test data is super big, means the images become super big. So then they need to be pulled down, but only once. And afterwards, they are cached in the Docker cache, which is definitely okay for the local developer machines. For the CI environment, then depends on your CI environment. If you have a CI environment that is more stable, that would keep the Docker cache alive, okay, it just gets pulled once, then you can live with it. If you spin up ephemeral new build nodes with every CI run, then it becomes expensive because every build, then all the data has to be pulled again. So really depends, like every good consultant, that's the only thing I can say, it depends. But I would say it works very good for a lot of enterprise context.
Okay, thank you. And the next question from Peter Michalisco. Is it possible to connect a test container with a mobile app iOS simulator? Have you tried it?
So I have been out of the of the mobile development industry for a long time, probably since my university time. So I don't know how you do it nowadays. So let me say it like this. If you can connect with the simulator to a, for example, locally running web server that would be reachable on localhost on your system, yes, if you can do this, then you can do the same with test containers. So you can spin up with test containers your application and then run it. So since I don't know how those mobile applications, the development is wired up, it might mean that you have one Java project that you start that will then spin up the system, and then maybe another project that runs in the iOS emulator or whatever. So I'm just too inexperienced to know this, but in theory it would work. Just the question is how you interact with the Docker daemon from the process at which you're running the tests. Yes.
Okay, thank you. And the next question from David. Do you also have a JavaScript Node.js fork?
Yep. Yes, we have. So I personally have not much experience with it because I'm just using and maintaining the Java one, but we have one that is officially part of our GitHub group. So it's under the Testcontainers banner, and it's actively maintained and developed. And I know like some bigger projects use it as well. Yes.
Okay, thank you. And another David, different David. What if I wanted to wrap my test automation framework or performance test stack in the image?
Yeah, I don't 100% understand the question, this context. You can put into the image whatever you want, but so what you could do, maybe this is the way the question is meant, you can wrap the whole test automation or performance testing. Let's do performance testing because this I know a little bit better. Let's assume we would do a load test using JMeter. Then you could do something like, okay, have an out of process description of those test environment with maybe the application you want to load test, and then another container that contains the JMeter, and then you start those up, and then you execute. And this you can do also from test containers. You execute some command in those performance testing container, maybe, that it would then trigger the test. So you can do this in general. If this is the best way, I don't know. Maybe I also misunderstood the question.
Okay, and here's the answer to your question from Peter Michalisko. Yes, we have a backend for our iOS app. That was the previous question about linking them to a iOS or a mobile app.
Yeah.
Okay.
So if you yeah. Okay. All right.
Okay. So David, very nice demo. I like how you integrated your environment infrastructure code with your actual testing code. So that's feedback. And finally, the question is your last demo, the one you demonstrated today, public available? Is it on GitHub?
Yeah, it is. It is there. Both. Everything I showed is in GitHub in my repository. I don't know where is the best way to share those links, I wonder. Here in the chat, no, they don't see it all.
No. If you send them to us, we'll distribute them after the...
Cool, then I shall do this, yeah.
Yeah. Okay. So that's the last question. Thank you very much, Kevin. I wasn't too intimidated. I think you were able to explain it in a way that even a total layman like myself could kind of understand what you were talking about and what the benefits were. So thank you very much for attending our conference today, for sharing your know-how. And I look forward to maybe seeing you sometime in person on a conference. I hope next year we'll have in-person conferences again.
Yes, okay. I hope so too.
Okay,
all right.
Thank you. Thank you. Say goodbye to our audience. Tell them a little bit about next week. Just to mention that part of the Tesena Fest were 4 workshops. We've already had 3 of those workshops. This week we had Christoph Bohner talking about from manual to automated testing for conversational AI. And the last workshop coming up is, I think again, this week. Somebody correct me if I know. It's next week, October the 4th. And it's Tarek King, A Beginner's Guide to AI-Driven Testing. And I'm signed up for that workshop, and I'm very much looking forward to seeing that. Okay, once again, next week, we're talking about the future of testing. 3 great speakers lined up. If you'd like to give us some feedback for today, we'd be delighted. There's a link on below the stream. And I look forward to seeing you all once again next week for the final week of this year's Tesena Fest. So goodbye and thank you.